Hey guys, welcome to the Engineering World. Here is the free mock test series for SSC JE Vizag Steel NLC. So, please subscribe the channel and support me. Here are the explain the solution of thermodynamics free mock test. You can give this test at any time. Link is in description box. First question is the number of degrees of freedom for a diatomic molecule. There are 3 translation and 2 rotational degree of freedom for diatomic molecule. So there are total 5 degree of freedom. Then which one of the following is the extensive property of a thermodynamic system? Extensive property means which depend on the mass of that system. Here volume is depend on a mass and other are independent of the mass. So the correct answer is volume. Next question. During a constant pressure expansion of gas, 33.3% heat is converted into work while temperature rises by 20 Kelvin. The specific heat of gas at constant pressure as a proportion of work W is. At constant pressure process, dq is equal to Cp dt. Given that dW is equal to 0.33 into dq, that is dq is equal to 3 times dw. Cp is equal to dq divided by dt, that is 3 into dw divided by 20. It gives 15% of dw. So correct answer 15%. Then the next question. A fluid flowing along a pipeline undergoes a throttling process from 10 bar to 1 bar is passing through a partially open valve. Before throttling, the specific volume of fluid is 0.5 meter cube per kg and after throttling is 2 meter cube per kg. What is the change in specific internal energy during the throttling process? In throttling process, enthalpy is constant, change in enthalpy is 0. So H1 is equal to H2. We know that H is equal to U plus PV, where U is internal energy, P is pressure, V is specific volume. So U1 plus P1 V1 is equal to U2 plus P2 V2. By putting all the values, we get U2 minus U1 or U1 minus U2 is equal to 300. Okay. Then Joule Thomson coefficient is the slope of. Here I will show the temperature pressure diagram, and this is a temperature pressure diagram, and these are the constant enthalpy lines, and slope of these enthalpy lines is the Joule Thomson coefficient. Okay, so the correct answer is Joule Thomson coefficient is a slope of constant enthalpy lines on TP diagram, that is answer is D. Then the next question. A gas is here flowing through an insulated nozzle. If the inlet velocity of gas is negligible and there is an enthalpy drop of 45 kJ per kg, the velocity of gas leaving the nozzle is. By applying the steady flow energy equation to the nozzle, that is H1 plus V1 square by 2000 is equal to H2 plus V2 square by 2000. Here V1 is 0 because here given inlet velocity of gas is negligible. So putting values, we get V2 is equal to in root of 2000 into dH. So V2 is equal to 300 meter per second. Then the next question. A heat pump working on a reversed Carnot cycle has a COP of 5. If it works like a refrigerator taking 1 kilowatt of work input, the refrigerating effect will be. We know that COP of refrigerator is equal to COP of heat pump minus 1. 1 minute I will show it. So COP of refrigerant is equal to COP of heat pump minus 1. So we get COP of refrigerant is equal to 5 minus 1 is equal to 4. Also COP of refrigerant is equal to refrigerant effect divided by work, that is let Q2 divided by W. Here W is 1 kilowatt, so Q2 is 4 kilowatt. Answer is 4 kilowatt. Then the next one. A reversible engine operates between temperature 900 Kelvin and T2. T2 less than 900, and another reversible engine between T2 and 400 in series. What is the value of T2 if work outputs of both engines are equal? Here I will show the series, these two engines are in series. So please concentrate on this diagram, as this is the ideal question, and only trick based on in this are if engine are in series and if engine are in series and they have equal work output, the intermediate temperature is arithmetic mean of other two, that is T2 is equal to that T1 plus T3 divided by 2, that is 900 plus 400 divided by 2. Here this is the sentence. So we get 650 Kelvin. Next question. A Carnot engine operates between 37 degrees Celsius and 347 degrees Celsius. If engine produces 620 kilojoule of work, the entropy change during heat addition is. We know that efficiency is equal to 1 minus T2 divided by T1. T2 given 37. We have to convert it into Kelvin. Also efficiency is equal to work divided by energy supplied. So by putting T2 and T1 as given, also by putting W, okay, first we get efficiency as a 0.5, then 0.5 is equal to W divided by Q1. So Q1 is equal to 620 divided by 0.5, that is 1240 kilojoule. Entropy change during addition is equal to heat addition divided by temperature at that point. So we get delta S is equal to 2 kilojoule per Kelvin. Then next question. During a thermodynamics process, 100 kilojoule of heat is transferred from a reservoir at 800 Kelvin to a sink at 400 Kelvin. The ambient temperature is 300 Kelvin. The loss of available energy is equal to T0 into delta S. Delta S change in the entropy. Here same heat is transformation, that is one is gaining the heat, other is losing the heat. So just it is a formula based question, so putting values we get 37.5 kilojoule. Then an ideal gas is flowing through an insulated pipe at a rate of 3.3 kilogram. There is a pressure drop of 15% from inlet to outlet of pipe. What is the rate of energy loss in kilowatt because of this pressure drop due to friction, given that R of gas 0.287 kilojoule per kg Kelvin and reference temperature as 300 Kelvin. Here there is a simple formula. We will see how it is arrived in a GATE-IES lecture series on same channel, YouTube channel. So this is formula. By putting all the values we get 42.62 kilowatt. So the next question is, for a pure substance, what are the number of thermodynamics degree of freedom for a saturated vapor and superheated vapor respectively? We know that we have to found it by Gibbs phase rule, which is P plus F is equal to C plus 2, where P is equal to number of phases, F degree of freedom, C number of components. For a saturated vapor, P, that is number of phases, is equal to 2, component 1, so we get F is equal to 1. And for a superheated vapor, phase only 1, that is only vapor, no any water content, so we get degree of freedom F is equal to 2. So the correct answer is 1 and 2. Then the specific volume of water when heated from 0 degrees Celsius. Actually it is an anomalous behavior of water, that is at 4 degrees Celsius its volume is the lowest, that is after 0 degrees Celsius it decreases up to the 4 degrees Celsius, and after that it increases. Then the next question, for the same maximum pressure and temperature, here I will show the PV diagram. This one is the Otto cycle, okay, and this one is the dual cycle, and this one is a diesel cycle. Here the compression ratio is for diesel cycle is maximum as compared to dual and Otto cycle, and hence efficiency of diesel cycle is greater. So correct answer is diesel cycle is more efficient than Otto and dual. Which cycle consists of 2 reversible isotherms and 2 reversible isobars? Simple, it's a Ericsson cycle. By the way guys, we are launching free subject-wise mock test every Sunday at 10 am for mechanical engineering students starting on 10th May 2020. Only registered students can apply. Link is in the description box. Then the next question. An Otto cycle has a compression ratio of 8. If 250 kJ of work is extracted from the cycle, heat rejected by the cycle is. Here I will draw the Otto cycle. This is a PV diagram. Here this one is the compression, okay, then constant volume, then constant volume heat rejection. So we have to find the heat rejected by the cycle. Compression ratio is given, so we know that efficiency of Otto cycle given by 1 minus 1 divided by Rk raised to gamma minus 1, where Rk is a compression ratio. Also efficiency is W, work done, divided by heat supplied, but heat supplied is a sum of heat rejected plus work. So putting the values we get Q2 is equal to 192.69. okay. Then the next question. For a same power output and same compression ratio as compared to 2-stroke engine, 4-stroke SI engine have, as there is a fuel loss of fuel during exhaust stroke in 2-stroke, hence 4-stroke has high efficiency. Then the next question. A reheat cycle in a steam power plant is mainly adapted to. I will show this is a reheat cycle. If there is no reheating, then 1 2 directly it will goes to this point, okay, but due to reheat it goes to this, that is moisture content decreases. So the correct answer is decrease the moisture content, okay. Then the next question. Here the gas turbine works on which one of the following cycle? It is a straightforward Brayton cycle, okay. Then the next question. Brayton cycle with infinite intercooling and reheat stages would approximate as a. This is a Brayton cycle with infinite intercooling and reheat stages. So it look like a Ericsson cycle as we seen earlier. So answer is the Ericsson cycle. This is Ericsson cycle. Then next question. The maximum net specific work obtainable in an ideal Brayton cycle for Tmax is equal to 900 Kelvin and Tmin is equal to 400 Kelvin is given by. Actually it is a formula based equation. Maximum net Cp root of Tmax minus root of Tmin, we get 100 Cp. The next question. The most common type of absorption system in use in industrial application is based on the refrigerant absorbent combination of. Answer is ammonia water. Straightforward question, general question, okay. Then in a VCR plant, the refrigerant leaves the compressor and evaporator with an enthalpy of 205 kJ per kg and 177 kJ per kg respectively. Enthalpy of refrigerant leaving the condenser is 105 kJ per kg. If mass flow rate of refrigerant is 0.2, refrigerant effect will be. Here is the vapor compression refrigeration cycle. This is given, okay. Compressor leaves, evaporator leaves 205, 177, then condenser leaves, and condenser and input of evaporator are same, that is H4 and H3 are same, and R effect that is refrigerant effect will is equal to M into H1 minus H4. By putting we get 14.4 kilowatt, okay. Next question. At a 100% relative humidity, the wet bulb temperature is. At 100% relative humidity, the dry bulb temperature is equal to wet bulb temperature is equal to dew point temperature. So the answer is same as dew point temperature. Okay. So the next question here, a certain air has a dBT dived bulb temperature of 35 degrees Celsius, dPT of 20 degrees Celsius. The corresponding saturation pressure of water being 5.628 kilopascal and 2.33 kilopascal respectively. When atmospheric pressure is assumed as 1.0132 bar, the specific humidity of air will be. Actually, it is a formula based question. Formula is 0.622 into PV upon P minus PV, where PV is a saturation pressure of that water. Okay, so putting we get 14.7 into 10 raised to minus 3. So in this way we conclude our this chapter, and please subscribe the channel. Also please register for a subject wise mock test. Okay, all the best. Thank you. Subscribe the channel.